Hello students, this is your lecture number 9 on digital electronics. In the last class, we have discussed about actually I have solved many problems on Boolean algebra as well as then how we can implement different logic expression or logic gates by using your universal gate, that is your NAND and NOR gate. I have given one homework also to implement one basic logic by using your NOR gate. Then I have started one most important gate, that is your exclusive OR gate or XOR gate. The symbol for this XOR gate is, this is the symbol. The minimum inputs required for your XOR gate is 2. You can apply more than 2 input also, but the minimum input required is 2. So if I apply 2 input, that is A and B, 2 input, that is A and B, then what is the expression for your XOR gate is Y is equal to A bar B or A B bar. This is the expression for your, this is the Boolean algebra for your XOR gate. And how you denote it? So this is the notation for your XOR gate. A XOR B. So this is symbol for your exclusive XOR. Then I have drawn the truth table, that is A B Y. XOR gate output is 1. The output of the XOR gate is 1 only when one of the input is 1. That is in this case, that is 0 1 when A is 0, B is 1, or A is 1, B is 0. In this case only the output of the XOR gate is 1. All other cases, that is both 0 and both 1, the output will be 0. So the important from this truth table, we have drawn a conclusion that if more than one input, more than 2 input applied to your exclusive OR gate, then how we will find that when the output of the XOR gate will be 1. That is the case that XOR gate is odd number of 1s detector. XOR gate is odd number of 1s detector. That is, suppose I have applied 4 inputs to your exclusive OR gate, and if the number of 1 in digital, we are applying 1 and 0 only as an input to the gate. So if I apply number of 1 is odd to the input, then the output of the exclusive OR gate is 1. Hence, one of the application of XOR gate is it acts as a odd number of 1s detector. Odd number of 1s detector. So now I am going to discuss its application, then its few application of exclusive OR gate, and then I will teach you about another gate, that is exclusive OR gate. So remember, this is the truth table and this is the expression for your exclusive OR gate, and this is the symbol for your XOR gate. This is the symbol for your XOR gate. So what are the application of exclusive OR gate? Where we are going to apply this exclusive OR gate. First is XOR gate used in adder circuit, bracket is modulo 2 addition. So in your computer or mobile phone, the addition are taking place by using modulo 2 addition, that is binary addition, and this addition is known as modulo 2 addition, and that addition is performed by your exclusive OR gate. So one of the application of exclusive OR gate is used in adder, that is your modulo 2 addition. It is also used in subtractor also. Second is odd number of wireless detector. So another application of exclusive OR gate is it acts as a odd number of wireless detector. That means if you apply odd number of 1 to the input of the exclusive OR gate, then only output of the exclusive OR gate is 1. Hence, we are using odd number of wireless detector. That is another application of exclusive OR gate. This XOR gate also used in XOR gate also used in subtractor circuits. Is also used in subtractor circuits. So these are the application of your exclusive OR gate. Then few operations that we are going to perform by using exclusive OR gate. So note it down. These are the three applications of exclusive OR gate. So next is exclusive OR gate act as an inverter. XOR as inverter. So when another application of this exclusive OR gate is when this gate act as an inverter. So I am applying here. Here I am applying one of the input is A and another input is grounded. Ground means you are applying 0. Ground means in electrical or electronics you are applying 0 input to this terminal. So then what will be the output of this gate? What will the output of this gate? You know. The output of XOR gate is generally written as A bar B or AB bar. So in place of B, I am now going to put the value 0 because this input is here grounded. That means what is the value of B? B is 0. So A bar and first is XOR as buffer plus XOR as buffer. Buffer means you are applying input A and you are getting output same as the input you have applied, but after some time delay. So when I apply, this is actually the circuit for XOR gate act as a buffer. XOR gate as buffer. So A bar and 0 or A, I am putting B value is 0. So 0 complement. 0 complement is 1. So A bar and with 0, anything added with 0 always equal to 0, or A and 0 bar. 0 bar means 0 complement means 1. So now this is A and with 1. From the AND logic we have drawn the conclusion. So finally we are getting. So we are applying input A and we are also getting output as A. We are also getting output as A. So in this way your exclusive OR gate will act as a buffer. The next case I am going to teach you. These are few applications. Mostly these questions they won't ask you in semester examination, but in any competitive examination you will find these types of question, MCQ based question. That means when one of the input is 0 in exclusive OR gate, then exclusive OR gate acts as this type of multiple choice question. They will ask exclusive OR gate acts as buffer, inverter, OR gate or AND gate. They will put some core option. Then you will find out the one of the option is correct, and you need to find out that option. So this type of question mostly they ask you from the application part in entrance examination or any type of competitive examination. So exert as inverter. So exclusive OR as inverter. So when this exclusive OR gate act like a inverter, that I am going to show you. So if one of the input is applied at A and another input is permanently applied to 1, so in this case 1 means you are applying with some source, that is some DC potential, that is VCC. So VCC means some potential, but we will treat in digital as it is as 1. So I am directly drawing this as 1. If pattern in question they will put here that one of the input is connected to 5 volt, you treat this 5 volt as logic 1. Treat this 5 volt as logic 1, and if the ground one of the terminal, that is denoted as logic 0. So grounding means in digital logic 0, and any plus 5 volt plus 10 volt, if you are applying such type of DC voltage, then that is denoted as logic 1 in case of your digital electronics. So then, how to find? And first of all, we know the expression for your exclusive OR gate, that is A bar B or A B bar. So here in place of B, I am applying one of the input as 1. So what I will put in place of B, that is B equal to 1. That is B equal to 1, because this is the generalized expression. In the generalized expression, I am applying A, B as input, but in this particular circuit, in this particular logic, I am applying one of the input is A and another input is 1. So in place of B, what I am going to write, that is what I am putting, that B equal to 1. So A bar and with 1 or A B bar, that means 1 bar. So A bar and with 1 is always equal to A bar, or A 1 bar. 1 bar means A and with 0, because 1 complement is 0. So A and 0 is 0. So obviously the output will be A bar. So obviously you are applying input A and you are getting output A is equal to A bar. So this gate now, this exclusive gate is now acting like a inverter. This exclusive gate is now acting like a inverter. So this type of question they might ask you in competitive examination. So keep that in mind and try to note it down and try to see how I am solving this type of problem. So you need to practice in order to have a command over digital electronics. See, this is the basic concept, and so that's why I am teaching very slowly as well as in details manner. After the basic logic gates, basic Boolean algebra, number system and Karman map, these are all over. Then we will somehow speed up our teaching. Obviously, in order to complete the entire syllabus, because we have some time constraint. And the next chapter is combination energy circuits. So in that combination energy circuits, I am going to once again using these logic gates as application. How to build, how to design an adder, how to design a subtractor, how to design a multiplexer, we will see. But these are the circuits. Why this name is combination circuit? Because these are the combination of logic gates. And this in today's class I am going to teach you about the till now I have been teaching you the basic gates, but in the latter chapter these basic gates are combined to form one of the circuits, combinational circuits. We will see that. So next, the last most important logic gates, the last gate, that is your XNOR gate. XNOR, or you can write like this, XNOR gate. So till now we have studied three basic gates, that is NOT gate, AND gate and OR gate. After that we studied universal gate, that is NAND gate and OR gate. Then another category of gate that is most important with respect to any combination circuits, that is your exclusive OR gate, and this is your exclusive NOR gate. So first we will see the symbol for this exclusive NOR gate. So how the symbol? Just like exclusive OR gate, and I am putting one bubble that denote exclusive NOR gate. That denotes the exclusive OR gate. So I am applying here input A, B. Then what is the output? Output here is denoted as A. In exclusive OR, plus and surrounded with a circle here, and encircled by a circle. So this symbol denoted as exclusive NOR gate. X NOR. So this is how denote exclusive NOR gate. Then truth table. Truth table for this exclusive NOR gate. So obviously we are applying two inputs, hence we have four input combination 0 0 0 1 1 0 and 1. So the output for this, that is exclusive OR gate, output will be 1 only when both the inputs are same. Only when both the inputs are same. So here 0 0 both the inputs are same. So output is 1, 0 1. Here obviously outputs inputs are different. One of the input is 0, another input is 1, hence output is 0. 1 0, also output is 0. 1 1. Here also both the inputs are same. Here also both the inputs are same, hence output is 1. So you can write here one statement. XNOR gate output is logic 1 only when all the input applied are same. Hence, another name for this exclusive OR gate is coincidence gate. Coincidence gate. So when the exclusive OR gate produce output 1 only when all the inputs are same. So in this case I am applying two inputs. So both the inputs are same, then only the output will be 1. So obviously there are two cases. In these two cases only, the output of the exclusive NOR gate is 1, and that two cases are when A, B both are 0, 0 or both are 1. Then only the output is 1, or in all other cases the output is 0. Hence, one of the important points I am going to discuss here. So that's the statement. This is the truth table. So then how to write this exclusive NOR gate? So expression for this A bar, B bar or AB. So if I open up this A exclusive NOR B, I will get A bar, B bar or A and B. In exclusive OR gate, the expression is A bar B or AB bar. For exclusive NOR gate, the expression is A bar and B bar. A bar and B bar or A and B. So this is the expression for your exclusive NOR gate. Note or application. So what are the application of this exclusive NOR gate? Where we are going to use this exclusive NOR gate? So exclusive we are using this exclusive NOR gate in comparator circuits. Comparator circuit. So that is comparator means we are applying two inputs here, A and B. So obviously, if you want to compare the two bits, that is A and B, then this gate is particularly used for them. That is, if A and B are 0, 0, then only output will be 1, or that is your equality. That is, if both the inputs are same, then only output is 1. If one of the input is 1 or another is 0, that is A is greater than B, then also obviously this gate output will be 0. So this gate is particularly used to compare between the two bits. Whenever we want to compare between the two inputs, we need such type of gate, and that gate is your exclusive NOR gate. So another is even number of 1s detector. So another application for this exclusive NOR gate is even number of 1s detector. We have seen that is the output of the exclusive NOR gate is 1 only when both the inputs are 0 or both the inputs are 1. So both the inputs are 1 means two inputs are 1. Here A is equal to 1, B is equal to 1. That is even number of 1. So even number of 1 is applied. Obviously, we are getting output as 1. So this gate is also used for even number of 1s detector. So this is another application of this exclusive NOR gate. There are many applications. I have written down just few applications in order to understand this exclusive NOR gate where we are going to use it. So remember, you have to remember three things. That is the basic symbol. Then how you denote this exclusive NOR gate. Then what is the actual expression for your exclusive NOR gate, and what are the application, your truth table for this exclusive NOR gate. So remember, student, this exclusive OR and exclusive NOR, these two questions they are asking repeatedly, many times they are asking this question, define your exclusive NOR gate and write down its few application. Draw the truth table for your exclusive NOR gate. So please revise that and kindly go through this lecture video, and if after any doubt arises, you can ask me. So this is the end of this logic gate. So till now we have studied about Just for your summarization, I am going to write it down. That's the logic gate summary. First, we will study about, this is the symbol for your inverter circuit. So this is your inverter. Here you are applying input A and getting output by equal to A bar. Then you have studied another gate, that is your AND gate. So this is the symbol for your AND gate. The minimum input for your AND gate is 2. So Y is equal to A and B. This is your AND gate. Then you have studied about OR gate. This is the symbol for your OR gate, and expression for your OR gate is A or B. This is your OR gate. Then fourth logic, that is these three are basic gates. These three comes under basic logic gates. Then fourth one we have studied here is your NAND gate. You are applying AB. NAND gate is a combination of AND NOT. So here and this denote your NAND gate. So Y is equal to NAND gate means A and B whole bar. A and B. So this is the symbol for your A and B, and this is not. So A and B whole bar is the expression for your NAND logic. And next one we have studied about A and B. So A or B whole bar. So this is for your NOR gate. And this comes under your universal gate. Then another gate we have studied. See, this is one of the important gate, that is your exclusive OR gate. Y is equal to A XOR B, and then the last one I have written here. Today system we have studied about this gate, that is your XOR gate as well as your XNOR gate. So total we have studied 7 gates, out of which the 3 gates are basic gates, that is your inverter and OR gate. Then we have studied about universal gate, that is NAND, NOR. Then we have studied about 2 important gates, that is exclusive OR gate and exclusive OR gate. So total we have studied 7 logic gates in Boolean algebra. So total we have studied 7 logic gates in digital electronics. So these are the logic gates, these are the basic gates, and in later module in your unit 2 we are going to use these gates for implementation of various combination circuits as well as sequential circuits. So please student, remember the symbol, the expression as well as the truth table. When this gate will produce the output as 1, this is very important, you need to know about that. The AND gate output is 1 only when both the inputs are 1. OR gate output is 1 only when one of the input is 1, otherwise it is 0, then also the output is 1. And similarly, you please revise all the logic symbol, please write it down on your board, and revise the truth table, the expression, and obviously practice Boolean algebra and the conclusion for each gate that I have written in the previous, that I have explained in details manner in previous lecture. So please go through that. Next, we will study about in the unit 1 itself the number system. After that, we will study about the Kannada. So thank you.